Welcome to Chapter 2, Psychological Research. Today we're going to talk about psychological research. Again, we're using this from Openstax Psychology 2E. So some research that might be done is, how does television content impact children's behavior? So why is research important? Before the scientific method, we relied on intuition. We had personal biases and opinions on how we should navigate reality. And as you can probably guess, this obviously didn't lead to the best outcomes. And this is why we need science and research utilizing empiricism so we can come to objective or unbiased conclusions about our world. So that we can follow through with them, so we can repeat them and come to the same conclusion. It used to be that people with mental difficulties were thought to be demonically possessed, or it was thought to be witchcraft. Thankfully, with the scientific method, we have improved tremendously. There's always room for growth. We do apply the scientific method to behavior and mental processes that are observable so we can reach repeatable conclusions that, again, are unbiased and are able to be proven. The hypotheses are able to be proven falsifiable, which is also important. So some of this we're going to come back to with deductive and inductive reasoning, but I'll start here. You can't get started with research until your hypothesis is able to be proven incorrect or it is falsifiable. As we all know, programs and institutions, businesses in general, constantly will claim that they're either their product or their method are based on scientific evidence. And it's important to be critical of anything that you see as science. So this is where this slide comes in about thinking critically about claims. You need to be critical and not take things as they're necessarily presented to you. You need to do more research to ensure that it actually is scientific evidence. Don't just rely on one piece of evidence to support your claims. Always do your due diligence, always fact check, get multiple opinions, and do your research to make sure that your claims are as unbiased as possible. When it comes to deductive versus inductive reasoning, science is like a tornado of improvement. It's constantly building upon itself over time. When it comes to deductive reasoning, is when we have broad generalizations or hypotheses and we turn them into specific conclusions about the real world. In science, we're not just satisfied at having one piece of evidence. We want to take all findings and make more hypotheses to then make more conclusions. That's why it can be called a tornado of improvements. Inductive reasoning, on the other hand, is when we take those specific conclusions to construct broad generalizations, then the process just continues to repeat over time. So deductive reasoning goes from general to specific, inductive goes from specific to general. A theory in science is one of the highest honors that you can get. It explains how an observed phenomenon has occurred. It has a well-developed set of ideas that are that support it. It does have research to support it, explaining why something happened. The scientific method starts with a question. Then we have to have a hypothesis, which is a testable prediction about the relationship between two or more variables. It predicts how the world will behave if the theory is correct. It's usually an if and then statement. Most importantly, it is falsifiable, as I mentioned before. Next, we have to test this hypothesis through unbiased measures. We have to eliminate bias as best we can, and we'll talk about some ways that we can eliminate those bias throughout the chapter. Next, we have to analyze the data that we come to. Once we analyze, then we can come to adequate conclusions. There's Freud and his conscious, and we talked a little bit in the last chapter about a lot of his theories have been thrown out, but they're still important. That's why we still learn about him. Even though some of his theories have been thrown out, psychology has definitely learned and grown as a result of his theories, even the ones that were thrown out. When we come to conclusions about our hypothesis, we need to report that information to an academic journal or article so it can be peer-reviewed and signed off. So now we're going to talk about some approaches to research. Clinical, case studies, naturalistic observations, surveys, archival research, as well as longitudinal cross-sectional research. When it comes to clinical or case studies, this is where we focus usually on just one individual. The difficulty with case studies is that we cannot generalize the information to the population at large. We can learn a lot about this particular individual, but we can't actually say what happened to this particular person is an indicator of what could happen to the population. An example is a case study about a girl named Jean. Unfortunately, she was held captive from birth and she was isolated, so she never really developed proper language. Because she was never exposed to language. Ultimately, she was found, but was never able to adequately learn language. She would try to make certain noises to signal and make signals, but ultimately language acquisition was significantly difficult. So the point of this is this would be specific to her situation and not necessarily something you could say any child that's put in isolation will not learn language. So that's an example of where a case study, you're finding valuable information, but you can't necessarily generalize that to the population at large. Next, naturalistic observations are experiments that can really get the most genuine and accurate behaviors out of the participants, but it's hard to set up. One of the things that's biased within naturalistic observation, when an individual is part of the study, that they know that they're being watched, and they may try to skew their behavior to align with the observer's expectations or what they think the observer is expecting. And if they don't know the observer's expectations, they will make ideas up in their head of what they think the observer wants. So that's also going to skew their behavior. This creates an observer's bias. It's important with naturalistic observation to make sure that the observer bias is eliminated, to make this as genuine and unbiased of a study as possible. Naturalistic observation is evidenced here with this is Jane Goodall, and she studied gorillas, which the movie Gorillas in the Mist is based on, for decades. Surveys are really convenient because they can be delivered in a multitude of ways, including paper and pencil. And now in this digitally advanced world, we can also deliver surveys digitally. You don't have to reconvene your participants. And the electronic surveys are good because it increases the individual's anonymity. So you definitely want it to be anonymous, and it's even easier to ensure that when you're doing surveys digitally. They're a really convenient form of archival research. Archival research utilizes others. Archival research can be convenient in the sense that you're utilizing other people's research to try to come to conclusions on your own hypothesis. The difficulty that lies in archival research is that you don't have any control, and you didn't have any control over how they conducted their study. So it may seem a little bit rigid or inorganic. Now talking about longitudinal and cross-sectional research. It's important to know the differences between the two. If we're conducting a study that is looking into the effects of smoking, maybe since the age of 18, you would collect for cross-sectional research. It takes a lot less time to do cross-sectional research because it's a segment of a population at a single time. So for example, you might get a group of 30-year-olds and 35-year-olds that smoked since the age of 18. The different groups we're looking at shows the effects of that smoking has impacted these people at the ages of 25, 30, and 35. So you're looking at those same segments of people at the same time. When it comes to longitudinal research, it'll give us more accurate data because it's looking at the same people. However, it takes a long time, which is why it's called longitudinal. In the same study that we were talking about with smoking, we check these people at 25, we check them at 30, and then at 35. So this would be a 10-year study to get that accurate data. Although it'd be nice to pull that off, the difficulty with the longitudinal research design is attrition or dropout rate. Because it's a longer study, so people are more likely to drop out and not continue with the study. When we analyze our test, we have to distinguish between a correlational research versus causation, as well as experimental research. One of the most important things that you'll learn in this class is that correlation does not equal causation. What correlation tells us is that there's a relationship between two or more variables. That one variable does something to the other. It can be in the same direction, or it can be in the opposite direction. But we know that when one variable moves, the other does as well. A positive correlation is when the variables move in the same direction. When one goes up, the other goes up. But also when one goes down, the other goes down. They're going in the same direction. When it comes to a negative correlation, it means that the variables are moving in different directions. When one variable goes up, the other will go down. When one variable goes down, the other goes up. It doesn't mean that the variable is causing the other. It could be something completely separate, another variable entirely, that's known as a confounding variable or a third-party variable. So it's something outside of the relationship that's causing both to move. If you look at the graph, at the bottom, you'll see these are the scatter plots. And it's just showing you the different directionalities that we referred to when we described positive, negative, and no correlation. Okay, and then here, if you notice on a graph that ice cream sales increase at the same time that crime rates increase, you're not going to think that there's a correlation between the two. I mean, that one causes the other. There might be a correlation, but there's no evidence that ice cream sales increasing causes crime to go up as well. The same thing would be if there was drowning involved in here. So what you might think is, okay, if ice cream sales are going up and there's drowning, that probably has to do with the time of year and people being outside more. So in this example, temperature is the confounding variable. So here again, correlation does not cause causation. Illusory correlations are seeing relationships between two things, but in reality, no such relationship exists. According to science, we would see an illusory correlation between or about astrology, for example. So many people believe in astrology, and I actually myself enjoy astrology, but you can't say that it's scientific, that it's based on scientific evidence. And so if you try to see that there's a relationship between astrology chart and something that happens to you, that would be an illusory correlation. It may appear that there's a relationship between the two things, but there's no evidence of that. Designing an experiment, when it comes to your experimental group versus your control group, your experimental group is the group that's going to receive the manipulated variable. The control group is simply who you're comparing that group to. If you wanted to see if a sleeping pill had an effect on a group of people, you would have one group that would be taking the sleeping pill, and you'd have one group that would be receiving a sugar pill. The actual sleeping pill would be the experimental group, and the sugar pill group would be the control group. The sugar pill would not actually cause any alteration. They should not feel anything as a result of taking it. So you're simply comparing the two groups. The experimental group will receive the sleeping pill, and you'll look at the differences between the experimental group and the control group. And you're hoping to find that the sleeping pill, the experimental group, is the only one that showed a change. A double-blind study is really good for eliminating bias on both ends. The dependent variable is the variable that you're manipulating. The dependent variable is what you are testing. Dependent variables are dependent on the independent variable. An example would be the idea that reading levels are affected by whether a person is born in the US or a foreign country. For this example, you'll try to identify what the independent variable is. So what are we manipulating? Our independent variable is going to be whether or not a person is born in the US. Our dependent variable, what is it's dependent on, is whether or not you're born in the US. But what you're actually testing is reading levels. So that's going to be your dependent variable. Selecting participants. Participants are the subjects of the psychological research. We have to make sure that it's random, that every single person in that population has an equal chance of being selected for participation. The sample is the adequate subset of individuals selected from the larger population. So we need a good size or group of individuals to be able to adequately represent a larger population. An example would be, if I were to go to the University of Tennessee, Knoxville, and I want to see the average height of students on that campus. Of course, I'm not going to go to the women's basketball team because that's going to skew and bias my data. I don't have what is known as a random sample, which means that every single person has an equal chance of being selected. So what I would do is I'd go to the quad area and I would try and measure at least 100 women, hoping that that's a good enough amount of women. And that would give me a decent sample, the subset of individuals that adequately represent the larger population. I'd probably get a pretty accurate average height of women at the University of Tennessee, Knoxville. Now, I said women, so that would only be the height of women, correct? When it comes to random assignment, this is the method of experimental group assignment in which all participants have an equal chance of being assigned to either group. So in the example of women's basketball, or not women's basketball, of women in the quad, that would not be considered random because it's only whoever was in the quad. It's not the whole school. If they're randomly assigned, then you're not picking people who may have a propensity for giving you the bias that supports your data. With random assignment, they don't know which group they're going into. It could be the control group or the experimental group. When your data has been collected, you need to determine statistical significance. The reason this is important is because of statistical analysis. It determines how likely any difference between experimental groups is due to chance. So if the odds of that difference are 5% or less, then the results are significant. And you can say that your hypothesis has been supported. We need to report our conclusions to continue to improve science. Usually your research is reported to scientific journals, and so it's usually aimed at an audience of professionals and scholars, and these articles are peer-reviewed. It's important to have others looking at your work who are legitimate so they can sign off and say, yep, this is adequate research, and it's repeatable. Just because something is reliable, because you get the same thing every time, does not mean that it's necessarily valid. So reliability is important when it comes to the idea that you get the same result, consistency, and reproducibility of a given result. But the information has to be valid. That information has to be accurate. When you're at an institution, you're going to have to adhere to an IRB, or Institutional Review Board. When you submit a proposal for research, they're going to determine if the ethics of the experiment are adequate. Informed consent is a form that your participants will fill out or checkmark or sign, where they know exactly what the study is about. They'll know the implications of the research, the potential risks that are involved, and that they know that their participation is strictly voluntary. They can leave at any point in time. They do not have to stay for the study. And most importantly, they have to be made aware that their information will always be kept confidential. Sometimes in science, deception is necessary. You purposely mislead an individual, but it's not going to harm the individual. It has to be deception that doesn't produce any sort of psychological torment or physical torment to the individual. Deception is misleading the individual so that you can get more genuine results. Because if they know exactly what the study is about, they're going to be biased and may have a tendency to either give you the results or maybe sway away from the results that you're after. We're trying to keep this as unbiased as possible. Now, if you do use deception, you have to debrief these individuals as soon as the experiment is over. And you have your results. You need to let the participant know exactly what the study was about. The last thing we're going to go over is ethics with animals. About 90% of psychological research involves animals, such as rodents or birds. They're used because their substitution is very similar to those in humans. But that doesn't mean you can just do whatever you want with these animals. You still have to aim to minimize pain or distress. Animals are useful to utilize when the research would be more unethical to use human participants. If you do decide to use animals, you're going to have to go through a whole other review board, as well as the Institutional Animal Care and Use Committee, or IAC. They review your proposal for research involving non-human animals, and they will sign off on it to say that this will be an adequate study to perform. I'll see you in Chapter 3.